All right, everybody, here we are for section 7.5, which is Avogadros Law. This is continuing in chapter 7, our gas laws chapter. But what Avogadros Law is that using pressure, volume, and temperature, you can calculate the number of moles or volume of a sample of gas that is at a constant temperature and pressure. Specifically, Avogadros Law, and the real crux of this is right here. Avogadros Law states that when the pressure and temperature are held constant, so unchanged, the volume of a sample of gas and the number of moles in that sample are directly proportional. Okay, so what that means effectively is if you increase the number of moles of a substance in a container, well, then the volume is going to increase as well. So let's go back to the top of the slide. Consider two gas samples that are identical. That is, they have the same pressure, volume, and temperature, and number of particles. If these two samples are combined, pressure and temperature do not change, but the volume and the number of particles has doubled. So to kind of visualize that, and this is, it's actually kind of straightforward, but let's go ahead and imagine that we have two identical containers and they each have these little dots indicating our particles of this gas. If you combine these two together, well, that's going to mean one larger container, so a larger volume, and, well, 2 times as many particles, or 2 times as many numbers of moles of that particular gas. Okay, so here's a nice visual of that. So we've got our state here, we've got our state here, and whenever they're combined, our pressure and volume, or our pressure and temperature remain the same, but our volume has doubled. Another way of visualizing that is this right here. So I'll call this chamber A and chamber B. This right here is to display a pressure. So we're applying this 2 kilogram mass upon this sample. Our temperature is 200 Kelvin. And then in chamber B, our 2 kilogram mass is applied and our temperature is 200 Kelvin. The only thing that has changed is the overall volume. This container, chamber A and chamber B, the volume has doubled, and the number of particles, molecules, whatever you want, however you want to phrase that, that has doubled as well. So that's effectively Avogadros Law. Now, in practice, we got something like this. A sample containing 22 grams of gaseous carbon dioxide. So I'm going to go ahead and write CO2. I'll put G, gas, occupies a volume, a V, equals 15.3 liters. What will the new volume be if an additional 15 grams of carbon dioxide are added with no change in temperature and pressure? Okay, so P and T are irrelevant effectively for this problem. Now, the thing that we need to do, and as we saw on the previous slide, we had an equation that was V sub 1 over N sub 1 is equal to V sub 2 over N sub 2. Okay, now V is our volume and N is the number of moles. So our initial volume, our V sub 1 is 15.3 liters. Our N sub 1 is, well, 22 grams of CO2. We need to convert that to, and I just know that carbon dioxide has a molar mass of 44 grams. CO2 is 1 mole. We have 0.5 moles of CO2 right here in our N sub 1. Now, N sub 2, do we know that? Yeah, we do. That is, well, I'm going to say 0.5 moles CO2 plus, remember this 15 grams, this additional 15 grams of carbon dioxide that we added. So I'm going to go ahead and do the molar conversion for that. It's 15 grams CO2 divided by 44 grams CO2 is 1 mole. CO2 equals. So 15 divided by 44 equals, and I'm just going to write this here, 0.34 moles CO2. So N sub 2 is equal to 0.84 moles. So now effectively what we've got is only one thing that we don't know, and that's our V sub 2. So we can set up this, I'll do it down here. V sub 1 is 15.3 divided by 0.5 is equal to V sub 2 over 0.84. Okay, so now what I'm going to do is the algebra to solve for V sub 2, so I'll do 15.3 times 0.8 divided by 0.5, and our V sub 2 is equal to 24.48. So that illustrates Avogadros Law. We've increased the amount of moles of carbon dioxide, we've increased the amount of our gas in this system, and what happened? Well, our volume went up. All right, I hope this is helpful, and I'll see you in the next section.